you an ordinary diploma student who is looking the place where you can learn the beauty of basic engineering and scientific mathematics? Possibly that might be one of your questions. But again, have you been looking the place where, or just the online institutions or online university or online schools or online institution where you can learn the basic engineering mathematics or the beauty of basic scientific mathematics? Possibly that might be your second question. So I would like to ask you, and I would like to tell you in advance, possibly today you met with the right answer for that question. How are you, everybody who is watching this program? My name is Olenjolai TAYAI Losingo. Simply just call me Olenjolai. I thank God by His own grace, He built in me a gift of teaching. And I thank God by His own grace, He built in me a gift of engineering. And I thank God by His own grace, He built in me a gift of loving science and applying science, that what we call engineering, in the field of engineering, because there are different aspects that you can apply science. In medical, you can apply science, in engineering. So I thank God by His own grace that He just gave me such kind of a special gift by His own grace. So I'm a national and international teacher who is going to teach you about the beauty of basic engineering and scientific mathematics for the ordinary diploma student. I would like to take this opportunity to welcome all the national and international viewers into one of our online institutions that called the Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai. There is no M. Simultaneously, we will be using different platforms to share our contents to every student worldwide without any boundaries of the physical space or physical locations. But right now we have one of our official YouTube channel that's called the Online Diploma Polyinstit of Tanzania, in square bracket Olenjolai. I understand among you who are watching these programs, you have already signed yourself or registered yourself to be a permanent student of OLPITO, or you are a new student in our online institution. I would like to take this opportunity to welcome all, just to call them all students and new students of ordinary diploma to enjoy the beauty of basic engineering in our channel. Then you can follow the 67 steps. Remember that we said mathematics will see at the sign, trigonometric identities. I know that you have a fundamental concept of trigonometry during your ordinary secondary education. So we'll just quickly remind you some concepts that which are very important, but we are focusing on building the new concept. And I want to tell you that when you are taking this concept, your friends, your classmates who are pursuing a high advanced secondary education are learning this topic also in advanced pure mathematics and also in basic applied mathematics, but also they have to cover closely to what you are covering, except in advanced pure mathematics, they used to cover so many contents compared to ordinary diploma level. I know that because I'm also a teacher of advanced pure mathematics for the Form 5 and Form 6. So let me start quickly on quick review of what we taught you in previous lectures. So quick review of lecture 3. In lecture 3, it has been titled as trigonometrical function. So just start with trigonometrical function. And they mentioned 6 trigonometrical functions and how do they relate. The first one is called the cosine. The second trigonometric functions, we say it is called what is sine. This we know them since O level. And the third one is called the tangent. Tangent. So this in mathematics, you'll see it as cos of the second angle. And this one in mathematics, you'll see at the sine. And this one is written in abbreviations as what as tangent. But again, to introduce to you new function, trigonometric functions, we call them reciprocal of trigonometrical functions. This reciprocal of trigonometrical function, the first one is called the second. Okay? Second, and this in mathematics, we use the symbol sec. And then switch the reciprocal 40, reciprocal of cosine. And then the 50 functions, we taught you about cosecant, which is the reciprocal of 40, cosecant, In abbreviations, we call it cosec. These are very important function. This is the reciprocal of sine, and then we have cotangent, which in mathematics, in most cases, will be referring is by using the abbreviations cot. So remember cot, this is taken from this one. Cosecant, this is taken from here. Then sec, this is the abbreviation taken from these three first letters. Tangent, this is taken from the three letters of 40 of tangent. The first is three letters of sine from sine. The first three letters of 40 of cosine from what is the cosine. And then we taught you about the relationship, how do they relate. If you do remember that, we said tangent of an angle theta, this is equal to sine of angle theta of 40 of a cosine of 40 of angle theta. But again, we say that sec of angle theta, this is equal to 1 over cosine of angle theta. Then we come cot of what? Cot of angle theta, this is equal to 1 over tangent of angle theta. But this also is equal to cosine of angle theta over sine of 40 of angle theta. Okay, so today let me focus or let me introduce to you a new function. We call it even function and the odd function. So let me teach you today a new function called even. You remember that in Form 1 we taught you about the even number. So this is even function and odd function. Even function and odd function. So ladies and gentlemen, stay with me. Even function and odd function. This is very important in applied science, and it's a very important concept in engineering, especially when we be dealing with concepts of Fourier integrals. And Fourier integrals, that's what we are applying actually in electronics, we apply in telecommunications, we are applying in different aspects of electrical engineering, because it's the cornerstones of electrical engineering. So that's why we are teaching you about odd and even function. Later on, we just recall it, and then we do maneuvers and solve the problems, then we quit, right? So let me start with the first one. The first one is called even function. We are not talking about even number. When you say about even number, when you refer the definition we gave you about even number, we define that an even number is a number which is divisible by 2 without a remainder. How about even trigonometrical function? So simply, we can have this question in our mind as mathematicians. What is even trigonometrical, because we are focusing on trigonometrical, right? Trigonometrical function, right? That's a simple question. So simply we say that even trigonometrical function, even trigonometrical function, we say that is any trigonometric function which obey the even condition of a function. Obey the even condition of the function. The function which is f negative x is equal to f(x). If you are using g to name the function, g of negative x, this is equal to g of x, right? If you are using h to name the function, h of negative x, this is equal to h of x. So this is the even condition in mathematics. Any function is said to be even if and only if satisfy this condition, that f negative x is equal to f of x. Means if you substitute the negative value of independent variable, the answer is positive. The answer, it means the value of that functions, or the functions will give you the positive value. Okay? So we say that this is the fact. So we say that only cosine and its reciprocal, which is called second trigonometric function, that are even. So only two functions into it. We have 60 trigonometric functions, right? We have 38 fundamental trigonometric function, and also we have, please, you can pause the video and copy the following steps for you to go through them, right? So thank you for copying, and thank you for sharing with other students who are in NK level 4 or NK level 5, so they can take advantage of this one in any Tanzania institutions, in any African institution. Okay. Okay. So if that's the case, we say that the condition is f of negative x. This is equal to f of x. That's the condition. Okay? So you say we have only two trigonometric functions. The first one we say that cosine. So remember, cosine in mathematics, we just write as cos of an angle. So remember that this is cosine of an angle. So what does it mean? It means that cosine of negative theta, this will always give us cos of positive theta. That's the meaning, right? Or if you have cosine of maybe a variable x or an angle x, cos of negative x, this will give us cos of positive x. So let us prove if it is true. Example. Okay, example. So it means that cosine of negative angle is equal to cosine of positive angle. That's the concept. So example. Let us find cosine of negative 45. Right? And then let us find cosine of positive 45. And then see if they are equal. So you may use the mathematical table as scientific calculator. Right? We advise all the ordinary diploma students to have original scientific calculator. And how or where can you get? Wonderful. You can get it from your local shops, or you can order it online in our online diploma library. Just we got an online diploma, Tanzania online diploma library. You can order the scientific calculator made by Casio, which is called Casio Function 901 MS, with a very affordable price. We have two products. The first product, it's called the Casio Function 901, means that the Casio FX function, function 991, number 1, and the Casio Function 991, number 2. So number 1 costs only 55,000 Tanzania shillings without shipping cost or without transport cost. And number 2, it costs only 35,000 Tanzania shillings. I want to warn you, there are an original Casio Function 991 scientific calculators in the market. So it's your decision, right? But we are, for example, this scientific calculator, I've been using it for 3 years without any kinds of the damage. So take your scientific calculator and then press or turn it on, then press the button written cos, then write cos of negative 45. So the response is 0.707, right? 0.741. So just write your answer in 4 decimal place. Then just clear the scientific calculator, then find cosine of positive 45. The response in 4 decimal places is 0.70771. Okay, so this is the first example. But I still have a doubt. What about the large angles? For example, we are looking cosine of negative, maybe we have an angle of 1250 degrees. Is this equal to, so that the question mark, right? Is this equal to what? Is this equal to cosine of what? Positive 1250 degrees. That's the question we have. So we have our scientific calculator, 380, and then write cosine. So let us do together. Okay? Cosine of negative 1250. This will make what? Negative 0.9848. Okay? Then again, we ask you that to find cosine of what? Cosine of 1250. And this one, it will give us negative 0.984, then 8 in 4 decimal places. Is this value equal to this value? The answer is yes. So regardless of any angle, so it means from those two angles, so it means that you see, you have realized it here that cosine of negative 45 degrees is equal to what? Cosine of positive 45 degrees. Then we say that cosine of what? Of negative 1200, negative 1250, this is equal to what? Cosine of 40, cosine of 1250 degrees. So that's why we say in general, cosine of negative angle is equal to, so generally, that's why that you say, generally, you have to bear in your mind from today onwards, until you die. Not until you graduate your ordinary diploma, until you die. But cosine of negative theta, this is equal to cosine of 40 of positive theta. In words, cosine of negative angle is equal to cosine of 40 of positive angle. That's the concept I was building about. Do you have any questions about even trigonometrical function? If you have any question, don't hesitate to ask in the comment section below. Wonderful. So let us go into the next step. The next assignment that I've been given by God today for you, I have a responsibility to teach you about all the trigonometrical function. Wonderful. So all the, say with me, all the trigonometrical function. Because why are we teaching you now? Because we taught you what the means of trigonometrical function. We taught you fundamental and reciprocal. So all the trigonometrical function. Okay? All the trigonometrical function. So we can have a second question that we have to ask ourselves as lovers of basic engineering and scientific mathematics. What is all the trigonometrical function? What is all the trigonometrical? So ask yourself, ask your neighbor if you are learning these contents as a group. Okay, what is all the trigonometrical function? What is all the trigonometrical function? That's the question that we have in our mind. Okay, so you have to remember, what, do you know anything about odd? Yeah, so odd is not a new vocabulary for you. A function is not a new vocabulary for you. But what did we teach you? We taught you about odd number. What the meanings of odd number? An odd number is a number which is divisible by 2 and has a remainder of 1. Is any number divisible by 2 and has a remainder of 1? Now that means that even, that's how we define all the trigonometrical function? No. So when it comes to the function, we should have what? The conditions, or we call it all the condition, right? The conditions or the even condition of a function. All the conditions of a function. So you say now, all trigonometrical function, you say that if the function is a trigonometrical, so if the trigonometrical is a trigonometrical function. Oh, So the Holy Spirit is still reminding me. How about sec? So this will be example 3. Okay, example 3. So example 3. So example 3, sec of what? Of negative 45 degree is equal to sec of positive 45 degree. Why? Because remember, sec is 1 over what? Cosec. It's 1 over cosine. So if you have 1, mean that if you have 1 cos of, okay, I think that, yes, anyway, so let me explain here. So sec of negative 45 degrees is equal to 1 over cos of negative 45 degree. What is cos negative 45 degree? It's 0.7071. Then on right hand side we have sec of 45 degree. This is equal to what? 1 over cos of positive 45 degrees. And that one will be 1 over 0.7071 in 4 decimal places. So that's why that we say cosine of the function. Yes, okay. Yeah, but I think that's it. Let me teach you about that because I have to strengthen you. You know, myself, I learned even function by using only the cosine, but later on I discovered myself because I love mathematics and I discovered about second also. It's an even function. So this is all about 30. This is all about 30 about cosine. Then we taught you reciprocal function that called the secant, which in mathematics will be using the symbol of sec. Right? So if that's the case, you say that sec of negative m, if it is an even, right? This one should be equal to sec of positive m. That's a general concept. Remember this. So means in terms of letters, sec of negative theta, this always should be equal to sec of theta. Why? Remember, sec of theta, this is equal to 1 over cos of negative theta. And this also is equal to 1 over cos of 40 of theta. Okay? Cos of theta. So that's the concept that you have to remember. Or you have to remember. So remember that, but simply say that, but cos of negative theta is equal to cos of 40 of positive theta. So that's why that I gave you example 3, okay, example 3, where that we are looking at sec of negative theta. Now, sec of 40, sec of negative 45 degree, this will be equal to what? Will be equal to 1 over what? Over cos of 40 of negative 45 degrees. So for that case, this will be equal to sec of negative 45 degree. This is equal to 1 over what is cos of negative 45 degree? 0.7071. Hence, we want to equate with sec of 40 or 45 degree. So sec of 45 degree, also this is equal to 1 over cos of 40 of positive 45. So this one is equal to 1 over 0.7071. So these are the two equal values. Two equal values. So that's all about 30, about all the trigonometrical functions. Do you have any question about all the trigonometrical function? Don't hesitate to ask in the comment section below. And don't also hesitate yourself to read the descriptions of this video for you to get more information about the proofs that we are teaching you. Ladies and gentlemen, the second concept that I have an assignment to teach you, which have been given by the Lord, is about 30 all the trigonometrical function. All the trigonometrical function. Say with me, all the trigonometric function. We taught you about all the function, possibly, in a certain concept. or we'll teach you later on. But you remember that the principle is the same, the condition is the same. So you have this fundamental question, which is question number 2. What is OD? What is OD? Trigonometric function. What is OD trigonometric function? That's the question we have on the spot. So simply say that OD trigonometric function, we say that if any trigonometric function which obeys the condition of what? Of OD function. Conditions of OD function, which is f of negative x, this is equal to negative f of x. Or if the notations of the function is g of negative x is equal to negative g of x. Or if you're using h of negative x, this will give us negative h of 40 of positive x. So that's the definition. Wow. So how many? Remember, uneven trigonometric functions cannot be an odd trigonometric function. So how many remaining trigonometric functions that we have which are not even? Right? Because we say that only cosine and the cosec and secant are even trigonometric functions. Then how about the 4 remaining? The 4 remaining trigonometric functions are odd trigonometric functions. That's the good news. Say that there are 4 odd. There are 4 odd trigonometric functions. Trigonometric functions. Namely what? First one is called what? Sine, which in mathematics I said we use this symbol. The second one is tangent, which in mathematics we use the symbol tan. Then the third one is reciprocal, which is what? Cosecant, which is simply means what? Cosec. Then the fourth one is cotangent, which is mainly what? Cot. In short. So you have 4 odd trigonometric functions. Wonderful. So what the condition? The condition is if you have f of x, to define this trigonometric function as x, then we say that is equal to f of negative x is equal to f of x. Or f of negative theta, which is commonly used is the commonly independent variable used for the angle. F of negative theta is equal to negative f of theta. Okay? So it depends. So it means for that case, for instance, if you start with sine, so sine of negative x, ladies and gentlemen, this will give us what? Negative sine of positive x. Or if you are dealing with sine of negative theta, this is equal to negative sine of angle theta. So this is 1. 2. Also, if you have what? If you have tangent of negative x, this is equal to negative, we'll do examples with you, negative tangent of 40 of x. Again, if you have tangent of negative theta, this is equal to negative tangent of positive theta. Okay? The third odd trigonometric function is what? Cosec. Cosec. So if you have cosec of negative x, this is equal to what? is equal to cosec negative, not negative cosec of what? Of x. If we have a variable theta, we say that cosec of negative theta, this is equal to negative cosec of angle theta. The first order trigonometric function is cotangent. If you have cotangent of negative x, this is equal to cotangent of x. And hence, if you have cotangent of negative theta, this is equal to negative cotangent of angle theta. So that's the fact. And you have to remember this for the rest of your life. Since I learned it, I have never forgotten. I remember that. And God is faithful. And I'm applying these concepts in my daily life. How about you? Are you applying mathematics in your life? I'm applying because I'm a musician. I'm learning music. And I see the concepts of mathematics in music. Wonderful. I'm also an electrical engineer. But professionally, I'm an electronics and telecommunication engineer formally. So let me give you some examples. So some examples. Okay. So these are just the general examples. Let us use the common angle, sine of negative 45. What the value of sine of negative 45? And then let us find negative sine of positive 45. What will be the response? How are you going to find the value of these two trigonometric functions? Just use your scientific calculator. Clear scientific calculator, press sine, then negative 45. Then so you get your team, the value is 0.7071. Then, how do we find negative sine 45 degrees? We have two alternatives. We can take negative 1, we multiply with sine of 40 or 45 degrees. So what do you get? So take negative 1 times sine of 40 of positive 45 degree. Okay, excuse me. You've been looking sine of negative 45. The answer is negative 0.7071. Then right now we are taking negative 1 times sine of 40 times sine of 45 degrees. So this is equal to negative 0.7 negative 0.7071. That's about 30, sir. Okay. So this is example 1. Let us go example 2. Let us think about cot. Find cot of what? Just let us take a special angle 45 of negative 45. Okay? And then let us find what? Negative cotangent of 45 degrees. How do you use scientific calculator? To find cot of negative 45, we have to take what? We have to take, okay, just in simple, cotangent, cot theta is equal to 1 over tan theta. Right? So to find cotangent of negative 45, that is equal to what? Okay, let me just write in simplified form for you, because I want my students to understand and eat this brain of mathematics and drink. So we have cotangent of what? So you have cotangent of negative 45. We are looking cotangent of negative 45. Ladies and gentlemen, this is equal to 1 over tangent of negative 45 degrees. Right? So you can use your scientific calculator. So this is 1. So use your scientific calculator to find tan of negative 45. So tan of negative 45. The answer is what? Tan of negative 45, the answer is negative 1. So 1 over negative 1, the final response is negative 1. Then we've been asking to find what? Negative cot of 40 of positive 45 degree. This is equal to what? It's equal to negative 1 over what? over tangent of what? Of 45 degrees. This is equal to what? So this is equal to -1 of what? Tan of 45, tangent, so use your scientific calculator, find tan of 45 degrees. This is equal to what? 1. So -1 over 1, this is equal to what? -1. So you can see that, hence shown, so you will see that cotangent of -45 degree is equal to what? Is equal to negative cotangent of 45 degrees. And that's implied that cotangent of negative x is equal to negative cotangent of negative x. Okay, so ladies and gentlemen, this is quiz. So try this quiz. So show that what? So show that cosec 120, so negative cosec 120 is equal to negative cosec 120. So is equal to negative, is equal to what? Is equal to cosec negative 120 degrees. So this is Roman 1. Roman 2. So this is quiz what? In every lecture, I will give you quizzes and I will give you what? Homeworks. Okay? So this is quiz 4. So quiz 4, and then we ask you to show that tangent of what? Tangents of -50 degree by using a scientific calculator is equal to negative tangent of what? Of 50 degrees. So if you do that quiz, you will have learned 4 essential examples that will give you a proof about all the geometrical function, and we agree that cosecant, sine, cotangent, and tangent are all the trigonometrical function. Do you have any questions about the trigonometrical function? If you have any, don't hesitate to ask in the comment section below there. I will answer your questions, and even also some other students, ordinary diploma students, worldwide can answer your questions, or even national level can answer your question. Okay, so according to the title of our lecture, I have to teach about even function and odd function. I have to teach about even function, odd functions, and unity cycle. So right now, ladies and gentlemen, let me take you and teach you about unity cycle, right? So let me teach you the third concept for this session, for this lecture, which is called the unity cycle. So you have to pay your attention because this is the review of what in ordinary secondary education in the topic called trigonometry during your learning of basic mathematics in Form 4. Or if you have pursued even in English mediums, that the process we are learning. Unity cycle. Say unity cycle. Unity cycle. So we have to ask ourselves as mathematicians. Okay? Question number 3. What is unity cycle? What do you mean? What is unity cycle? You have to listen carefully because these are useful concepts in mathematics. These are useful concepts in learning engineering. These are useful concepts in learning science. When I speak about these are useful concepts in learning mathematics, think beyond your classrooms of your present or future institution. When I speak about these concepts are used in applied in engineering, think outside of your class. Possibly that in your class you won't be taught how you apply in real life. When I say that these concepts are applied in science, similarly, you have to think outside of the classroom instructions you are receiving formally. So you have to challenge yourself and you have to ask yourself, why am I learning about unity cycle? Where can I apply this concept? Okay, one of our applications, I know that that's common in most students, even myself, I was in that phase. I will apply to answer questions about it in an examination, in test 1 or test 2 or in final exams. That is one of the objectives. But why are we teaching you? Why are we spending time and preparing the contents and summarizing and giving you examples about even function, odd functions, and the unit cycle? I have told you the real-life applications of odd and even functions. Those are applied in learning different concepts of Fourier series and Fourier integrals and Fourier transform. And those concepts are used in telecommunications, are used in modulations, principles of information, right? So they're simply just they're used in Fourier series, right? So you have to remember them. And because I'm teaching undergraduate students and I have a topic, I have a responsibility to teach undergraduate students about Fourier series. I have a responsibility to teach them about Fourier integral. I have a responsibility to teach them about the Fourier transform. And I have a responsibility to teach them about Fourier inverse transform. So I will recall and even I will remind you about odd and even function. But that's not enough. That's still what the applications in applied mathematics, but still in class. In real life, we apply the process of transform. Transforming the signal is kind of just mean that we'll be teaching you the concept. For example, this voice signal that I'm producing right now, it's a complex signal to be transmitted in air. So what we do, we have to transform this original signal into another simplified form, and then at the receiving ends, we have to retransform to restore original information. Wonderful. So many electronics devices, many electronics equipments, many telecommunication equipments, many telecommunication devices are using the principles or are using the concepts of odd and even function because it depends on the variable that you are given. Right? When you say variables, remember that when you have a function, then just think about the keypad of your mobile phone. You're just injecting, but you're clicking was the binary numbers behind it, which is 8 bits. Okay, don't want to go into too much detail. Let me focus on the questions. Ladies and gentlemen, pause the video, ask yourself, what the meaning of unit cycle in trigonometry? Simply, this is simple. Unit means 1, right? So we say that unity cycle is any cycle whose radius is 1. So the concepts of unit cycle actually that in integrating the concepts of coordinate geometry and the trigonometrical function. So I say that simply this is have to be the concept of unit cycle in trigonometry. In trigonometric function, show us the relationship between what? The relationship between coordinate geometry and the trigonometry. When I say trigonometry, it means angles and function. So here it means angles and what? And functions. How does it relate? So remember that when you say about coordinate geometry in two planes, not in 3 planes. 3 planes we think about vector. So this is always, you say it is y-axis and this is x-axis. This one we call it is positive side of y-axis and this is negative side of y-axis. This we call it is positive x-axis and this is negative x-axis. So that's about what? Geometry. So this is about geometry. And this is figure 4.1. About unity cycle, a cycle should have a center, right? So we say we have a unity cycle. I'll be trying to draw a unity cycle, but you should use your protractor to draw exactly unity cycle. So let me suppose that this is the center. So we say about unity cycle, so this is center, and then we say that radius of this cycle is 1. So distance from the center to this point is 1. And distance from the center to this point, let's say this is point A, and this is point B, is 1. That's the meanings of what? Unity cycle. So this is figure 4.1b. So now we want to integrate them. We have a unity cycle, and then we have a geometry, or geometric plane. If we integrate them, then we have to think about, we have also to think in terms of trigonometry. So if we integrate them, so we draw them in the single figure, what can we notice? So you get a unit cycle used in coordinate geometry. Okay? So right now, okay, suppose you have to draw a plane unit cycle. I will try my level best. So this one shows a relationship between what? Between the coordinate geometry or the geometry and what? And trigonometry. So ladies and gentlemen, let us focus on figure 4.2, which is unity cycle. I have drawn the y-axis as usual that we used to draw in geometry, and the x-axis. Alright? So this is the positive y-axis and this negative y-axis. This is positive x-axis, this is negative x-axis. And then this is the cycle. So this is our unity cycle. This unity cycle. So listen carefully, I'm going to summarize about the unity cycle. So this concept, if that's a cycle, then you know how do we relate with the concepts of angles? Because we have the two axes, x and y axis. So the concepts of angles, we can relate it in form of what? Suppose that usual, this positive x-axis is labeled as 0 degree. Then if you rotate anti-clockwise, okay, then here you find 90 degrees. And then if you keep on rotating anti-clockwise from this point, then this angle is named as 180 degrees. If you keep on rotating the angle, which is right angle, so this is, remember 90 degree, 90 degree, right? So simply say that this is equal to 270 degree. Then here it is. So you have 360 degree. Okay. So that's the single rotation. This is called anti-clockwise rotation. So how do we relate the concepts of the triangle with cycle? Remember, this is the unit cycle. So the radius of this cycle is 1, right? So this is the radius of the cycle. So from here, we can construct a right angle triangle. So when you construct this right angle triangle, then we have 3 sides. We already have a right angle triangle. So that's why that we can find intersection between the coordinate, between the geometry and trigonometric function. For example, this might be an angle, which is angle theta. So you know that this is adjacent, this is opposite side, adjacent hypotenuse of the triangle. Again, we can also have another right angle triangle. We can develop a right angle triangle because remember that the radius of this of this cycle, of this, we call it, because right now, we can call it, this is what, quarter cycle. So this is right angle, right? Again, here we can compose another right angle triangle. And this right angle triangle is in this form. So suppose that this is point A, this is point B, this is point C. Also, we can construct a right angle triangle with radius between the radius and the x-axis of the geometry. So this is, suppose this point D. Okay? Again, remember that this we call the first quadrant. This we call the first quadrant, and this we call the second quadrant, and this we call the third quadrant, and this we call the fourth quadrant. The concept of unit circle is a very essential concept in trigonometry. So, if we define the angle, if you have an angle theta here, right? So this is 0 degree less than theta, less than what? 90 degrees. Also, if you define the angle between, so the angles in this second quadrant, so the angles in this second quadrant, they mean that also the angle difference between 180 degrees and 90 degrees is actually 90. But now, if we come into the second quadrant, if you rotate from this point, then this one, we say the angle in second quadrant range from what? So range from 90 degree to what? So range between 90 degree and what? And the 180 degrees. Similarly, here also we have what? We have the range of the angle in the third quadrant is 180 degrees, less than theta, less than 270 degrees. Then here we are. So the range of the angle between here is 270, less than theta, less than 360 degrees. Okay. So these are the definitions of first quadrant in terms of range of angle, second quadrant, third quadrant, and fourth quadrant. With this definition, when we come into the contextuality of trigonometry, then we have to remind you a simple formula that we had in basic mathematics of ordinary secondary education. We used to say that we have a simple formula of all students. So we just remind you this formula, all students of Tanzania takes what? All students take what? Civics. What does it mean? In the first quadrant, sine of the angle is positive. Cosine of the angle is positive. And tangent of the angle is positive. That's the meanings of all three fundamental trigonometric functions in the first quadrant are positive. So whenever you're finding sine of 45, sine of 90, or you're looking for the cosine of 70 degrees, you're looking tangent of 15 degrees, you'll find that its value is positive. So that's why that this, we say that all the three trigonometric functions are positive in the first quadrant. Again, we say that students stand for sine. So in the second quadrant, if you are looking the sine of the angle that range in the second quadrant, only sine of these angles, of this interval of the angles, is positive. That's why we have S, at the meanings of S. And then take this representing what? The first letter of tangent. So what does it mean? So in the second quadrant, cosine and tangent of the angles between 90 degrees and 180 degrees is negative. When you come into the third quadrant, so we have tangent. So tangent of the angles between 180 degrees and 270 degrees is only positive. Is only positive, or is only positive. Cosine and sine of the angles between 180 degrees and the 270 degrees are negative values. So series here stand for the trigonometric function, which is called the cosine. So cosine of any angle between 270 degrees and the 360 degrees is only or is positive. But tangent and the sine of the angles between 270 degrees and 360 degrees is what? Is positive. Is negative. So sine and tangent of 270 degrees and 360 degrees is only or is positive. Okay? So that's a point that you have to remember. So this kind of definitions, it can simplify, or it has so many applications in trigonometry that we'll be discussing from point to point. So remember the concepts of unit circle, because for example, if you do, so another thing that I would like to talk about unit circle, which can help you. This is the first revolution. So for the first revolutions, we start from 0 degrees, we go into 90 degrees, 180 degrees, 270 degrees, then 360. But we can make the second revolution, because this is the first revolution. So the second revolution, we start from 360 degrees, then we move up to it. So here we have another angle, which will be at 360 degrees plus 90 is equal to 450 degrees. Then this one also, it will be forming what? So to be forming, this will be at 540 degrees. And then here we say that this one. So here we have what? 540 plus 90. This will make what? 600. So it means that 630. 630. So then we do the second revolution at this point. So 630 degrees plus 90 degrees, this will make it 720 degrees. So you can make also the second revolution, you can make the first revolution, you can make the fifth revolution, you can make the 10th revolution. So you can make so many revolutions, and as long as you revolve the number of Einstein, also the angle is going to increase. So for instance, in the third revolution, you take 720 degrees plus 90. So this will make your 800. So you make 800. So plus 90, okay, so plus 90, 810. Right? So again, if you add this 90, so you find that here we have another angle which is 900 degrees. And here we have 40. So you have 990 degrees. So add 90 again. So this will make your 1080 degrees. So that's the third revolution. So you can go to the first revolution and fifth revolution, etc., etc., etc. So what? So let me show you one application, so 40 of unity cycle, and then I will end the session for you. Okay, I'll end the session for you. I'm about to end this session, this lecture. So let me give you one of the example which will give you the clear understanding of 40, clear understanding of unit cycle, why I was teaching you the concepts of unity cycle. So you have this example. So this is example. I don't remember exactly the number of examples. So let's say example A. So you can find question in Trigi that ask you to evaluate it. Evaluate without using calculator. Evaluate without using calculator. So evaluate without using what? Calculator. So A, we have what? Sine of what? sine of 1080 degrees. B, we have to evaluate cosine of, so we have a scientific calculator of 1140 degrees. Then C, we have sine of what? 1470 degrees. So this is homework, and this is homework 4, and this also is a homework 5. Homework 4, again, homework 4A, homework 4B. So I will solve this one. So we've been asked to evaluate results using calculator. Okay? So this is the concept, so solution. Okay? So we say that the technique you have to remember, also the concepts of what? The concepts of revolution. Okay? So you have to check. So it means that, for example here, okay, let me do this one and then I'll do this one for you. So for example, in Roman A, we are looking sine of what? 1080 degrees. Okay? So 1080 degrees. So the first step, we say that refer unity circle in figure that we taught you in figure 4.2 above. Okay, in previous part. So it means that 1080 degrees is what? Is special angle, of what? Of 30 revolution. So for that case, sine of 0 degree is equal to sine of 360 degrees is equal to sine of 720 degrees is equal to the sine of 1080 degrees. That's the principle. Okay? So simply say that 1080 degrees lies what? Lies or not on the x-axis. So for that reason, we say that no need to use this the special angle. So sine of 1080 degrees. So we say that 1080 degrees is the special angle. So if you're a special angle, you as ordinary diploma students, you have to know how you can find sine, cosine, and tangent. It's a special angle. So because it's a special angle, so we have been asked to find out sine of 1080 degrees. This is equal to sine of what? Of 0. This is equal to sine of 360 degrees. And this is equal to what? This is equal to 0. So therefore, sine of 1080 degrees, this is equal to 0. Okay. Okay? Then we go for Roman B. Roman B, we are looking cosine of what? Cosine of 1040 degrees. So, solution. And then I'll give the homework for you. You have to think, we should not use a scientific calculator. So if that's the case, we should not use a mathematical table. We are limited in this question. If that's the case, you say that 1140 degrees, this is greater than 1080 degrees. Okay? So if it's greater than 1080 degrees, so this is now is an angle in between of force revolution, right? Of force revolution. Because after the first revolution, we say that 1140 degrees, this is less than 1440 degrees. So it means that it's in between. So simply say that 1080 degrees, this is less than 1140 degrees and less than 1440 degrees. So if that's the case, you say that we go for it. This is the first step. So the second step, you have to take this large angle minus this small angle, right? So you say that we've been asked to find cosine of 40 of 1140 degrees. This is equal to what? Cosine of what? Cosine of 1140 degrees minus 1080 degrees. So this will make what? Cosine of what? 1140 degrees. Okay, so this will make what? So 0, 14, so 16, and then this is cosine of what? So 0 minus 0 to 0, 14 minus 8, it's 6 to 6, and then 10 minus, and you have what? It is 60 degrees. So now you can note that cosine of 1140 degrees is equal to what? Cosine of 60. So 60 also, it's a special angle. Okay? It's a special angle. So without using the scientific calculator, just remember the principle we taught you on how you can find the cosine of 0, cosine of 45, cosine of 60, and cosine of 90 as a special angle. Okay? So when you do your computation, you'll find that cosine of 60 is equal to a half. Is equal to a half. So for that case, you say therefore, without using scientific calculator, cosine of 1140 degrees is equal to a half. So that's the response for that question. So try for this one, which is 1000 sine of 1470 degrees. And you can try also other questions as well as you can. Whenever you find, most of the questions ask you evaluate or find the value without using calculators. It means that the concepts of unity cycle actually eliminate us from our dependence on finding the sine or cosine or the tangent of the angles in trigonometry. So ladies and gentlemen, this is the end of lecture 4. I thank God who have given you an opportunity to join me. I would like to invite you in the next lecture, which will be the lecture 5, which will be titled with the word compound angle, double angle, and T formula, if the times will give us an opportunity. So make sure you don't miss it, and then we'll be teaching you how you can use all of these concepts on solving problems. Stay tuned to keep enjoying the beauty of basic engineering mathematics and basic scientific mathematics for ordinary diploma students. As long as I used to challenge you, think outside of the class and outside of the classroom instructions, even the one that I'm giving myself, and think where can you apply this information in your present and future life. So in case also, I would like to insist you, remember to register yourself in our official YouTube channel so that you can get notifications and online access of our contents. So keep inviting your friends, tell them the good news about what we are doing for you and what we are doing for ordinary diploma of the present and future generation. So this is Olenjolai. Remember that I don't know everything about trigonometric, vectors, and complex number. I just know small portions of it, but I have a responsibility to teach others who want to know about it. Think this is the challenge that I would like to leave to you. What problems can you solve in your daily life? Think about that question and communicate with me or interact with me in the comment section. So may God bless you and keep you until we meet in the next lecture.